Hi again, everyone. Welcome back to episode 2 of Electrosurgery demonstration. In our previous episode or class, we went through the electrosurgical unit. We discussed the different waveforms and modes. We discussed about the various effects that we want to see, and we said vaporization, desiccation, fulguration as our effects of interest. We discussed about the return electrode and the monopolar circuit. We discussed about the variables, the various variables that actually change the effect that we want on our instrument. Now to go on further, we'll start off with the same effects. So when we go on about the ohms, there is something about the Ohm's law, which is the electricity follows the path of least resistance. So when we have, for example, an abdomen which has previous scars and has adhesions. Just give you an example. These are practical scenarios now that I'm going to give you as we move further. So in that case, let's assume there is a bowel pulled up with an adhesion strand to the anterior abdominal wall. So when you're trying to cut that anterior abdominal wall strand, if it is a very fine, thin strand, remember we mentioned that the adhesion band has very high resistance. So when you try to burst that, one, it will not respond very well to cut with this. So you may have to increase sometimes your setting. When you do that, the adhesion band will find its path of least resistance, and along that strand, wherever it's attached to the bowel has very good conductivity. It will burn that tissue there. So the temperature will really increase. So you have to be extremely careful when burning a fine strand attached to the bowel, for example. You will cause a burn in the bowel without directly touching the bowel. So please remember that. Second thing is when we go on to a very practical scenario that we all work with. When we use, even in an open surgery, we have cut open the abdomen. You've seen vessels that are oozing or bleeding, spurters. You take arteries or hemostats and you hold them. The next thing you do is you tell your assistant to go and burst these vessels. So what is the normal mode that we would all use? I know more than 90% of you, if you can write your answer in the comment box, but I know 90% of you would probably select the blue because that's what is commonly done. And I'm boldly telling you, you are wrong. Why? Because that is a high voltage and a dangerous mode. If you remember what I said, it's like a lightning strike on and off. So let's give you a scenario that I believe most of you would agree to. Number one, when you are doing that, how many of you have experienced a sudden, like a shock or a burn in your hand or finger, and then you removed your glove only to realize there was a burn on your hand, and when you looked at the glove, you found that there was a hole in the glove. And the next thing you would say is, look, these are poor quality gloves, all right? Next time, don't give me such gloves. Get me those heavy duty gloves. The issue was not the quality of the glove. The glove was not there already with a hole in it. So what happened is when you use the blue, it actually found a way, a stray current found a way out through you and down to the ground, to the electricity. So that is what caused your burn. It's not an electric shock, it's a burn. Now, if you use the yellow in that scenario, like this, you hold it and you use the yellow, then you would not get burnt. Why? Because it's a low voltage current and you're supposed to use the low voltage current to buzz that vessel. So it's very important that you understand when you have held a vessel and you have told to burn it, you would use the yellow and it will burn the vessel. Exactly what you saw me do. Hold it, activate it, and it burns. So this is how we would advise you to use it. So the rules about buzzing a vessel using a hemostat is, number one, hold the vessel, not a big, don't hold it wide, hold it narrow. So try to pinpoint the vessel you're holding. Second thing is use the low voltage yellow cut mode. 3, use the low voltage cut mode with contact. So you see, you don't activate it in air and then come here. You will see sparks, see? So you don't want sparks here. See that spark? You don't want that spark. So you contact it and then you activate it. It will buzz there, it will not buzz here. See, no spark here. So please, number 1, low voltage cut mode. Number 2, fine holding. Number 3, contact, not non-contact, and you will get the best effect on that vessel. So this is what we are supposed to be using to use it as a hemostat. Okay, so the next thing about some of the practical aspects that we want to do is, yes, when you're doing laparoscopy, give me the laparoscopy instrument, the long one. When you're doing laparoscopy now, when you're activating this, for example, you can see here, okay? So there, so you can see. So that's laparoscopy, where you want to go and buzz some tissue or a vessel or something there, or use it for dissection and separate out adhesions. The issue is you are doing it through a long instrument. So it's important to understand in laparoscopy, when you are going to try and buzz tissue, try not to activate too much in air. Don't activate it here. When you activate it here, if there is bowel nearby, the electricity will jump from here to the bowel nearby. So if this is your target organ, always go close to the target organ before you activate it, and then you will see it jump. So when I do this, okay, so the rules about not activating in air is because when you activate an instrument far from its target organ, whatever structure is close by, the electricity might concentrate here and jump off to that target organ, non-target organ, which can be dangerous in that situation, causing burns in areas that you did not want. The next thing, now we will go into a few other aspects about monopolar energy. Monopolar energy has a few setbacks. So what are the negatives or setbacks about monopolar energy? Number 1, monopolar energy has a negative about something called direct coupling. It has a setback in the form of capacitive coupling, and it has another setback in the form of insulation failure. So these 3 are dangers of monopolar energy use, and it's important that we know how to circumvent this. So let's do a little bit of demonstration. Light down a bit, tube light. So I want to show you something as we then explain further about it. So you can see here, so what have I done? I have wound this cable around this around this fluorescent tube. And when I activate it, see what happens. So you start wondering, what am I doing here that we are activating this tube? And the reason is this winding of the cable around it happens to be what is called a capacitor. A capacitor is when you have 2 electrodes separated by an insulator. So you will get the electricity collect inside that structure. So when you have something like this, in practical aspects, what do I mean? Let's assume this is the cable of electrosurgery, and you have your nurse go and wind it up like this, and then put it on a towel clip here, okay? On a towel clip here, and then we are locking this up on the patient. So when I'm activating this on my patient here, there is electricity collecting around this cable and around this instrument, okay? Due to capacitating coupling. Now, this electricity that will collect through here, after it reaches a certain amount in collection, it will jump through and go to the patient under, on the skin, and cause a burn here. And you'll wonder why you got a burn here when all you did was operate here and nothing here. But the reason was you wound this cable around a conductor. So do not wind any cable of electricity around a conductor. That is going to be dangerous, and you will eventually cause collection of electricity here, and it will eventually jump off to the patient. So that is capacitive coupling. Now, I'll give you another example. Again, lights off. This time I may need more lights off. So I want us to see something very closely here. Now, see here, we have a conductor inside. Just turn on the lights a little bit. We have the metal conductor inside. We have an insulator, and we have a conductor. So conductor separated by an insulator. This is actually a capacitor. So what happens is when I'm activating this, see what happens. It is burning the tissue where you want, right? That's all we are doing. Now, please remember, this is on the patient. This is on the patient. Now, see what I'm doing here, all right? Now, I want you to see closely. I hope you will be able to see it. Can you see some sparks there? Now, look here. Can you see sparks there? Okay, so that spark that you saw here, turn on the light, you would now wonder why you would get a spark on this trocar when I'm operating through here. Now, what does that mean? That when you have this trocar is actually having electricity going through it and collecting as a capacitor. So, you would start wondering, why then does it not burn this patient's abdominal wall? Well, it does. But remember, if the abdominal wall is a bit wide, so for example, it's that wide, then you're talking of thin in, thin out, burn. Thin in, broad out. So you see if there is some electricity collecting here, but this is a broad surface that it is touching the abdominal wall. It distributes it along this whole abdominal wall, and there is no burn. But now, where is it practical? It is practical in one aspect. If you have a very thin patient with a wall thickness that is just that much, then you are using too much of energy, and you make the mistake of using the blue, which is the high voltage. This area will slowly get charred around here, around the port. And then when you have finished the surgery and you seal this off, you may realize that that port does not heal quickly. It does not heal quickly because you've probably like burnt up part of it and it is not now too much of viable tissue. So when you're trying to stitch it together, it won't heal that quickly. So that is a practical aspect about capacitive coupling, and especially in a very thin patient. So how do you prevent that? Number one, if it is a very thin patient, try a plastic trocar. There is no collection of electricity here because this is conductor, insulator, insulator. So this is safe. This is safe. But be careful in thin patients. And if you're in thin patients, don't overdo electrosurgery when it is like this. Or if you have to, please use the yellow cut mode, which is the low voltage mode, more often than the blue. I'll tell you where to use the blue. It's not as simple as use the blue for coagulation and use the yellow for cutting. No. The next thing is, this is also safe. So you have a 10 millimeter, you have a reducer, and you do this. This is also safe. Okay? But the one thing you would never do is make a hybrid trocar. So what is a hybrid trocar? Let's say you're using a plastic trocar and this is leaking. So what do? You would like, this thing is leaking, it's making noise. Let me put in a reducer, a metal reducer, and you do this. Now this is a hybrid trocar. This is extremely dangerous when using electrosurgery. Why is it dangerous? Because you have electrode, insulator, electrode, insulator. So this insulator on the skin therefore cannot dissipate the electricity because it is an insulator. So where is the electricity collecting? On this second trocar inside, the reducer, the metal. If it's collecting here and there is a lot of, it collects a lot, I'm operating there, but after a while this is collected enough. If this is bowel nearby, it will throw a spark onto that bowel. And when it throws a spark onto that bowel, the next thing you know is you've caused a burn on the bowel. End of story. So this is called a hybrid trocar. Never, ever, ever use a hybrid trocar for electrosurgery. Okay? If you're ever to use that scenario, use it only with cold instruments. Okay? So, we have covered capacitive coupling, we have covered the electromagnetic field that creates correction of electricity, we have given you the rules and regulations of what kind of trocar system to use to make it safe for our patient. Do not make a hybrid trocar. Next risk is direct coupling. So what is direct coupling? Bring that instrument and touch this, just hold it somewhere. So you have held it by mistake. I'm going close, and when I touch that, when I activate it, so I made a mistake of touching the other instrument that this thing was touching. So what I was touching got burnt, and what this instrument was touching also got burnt. So it means that is direct coupling of these two instruments in there. So be very careful when you go to a close instrument, two instruments close to each other, and you're trying to use electricity on one. Be careful, the other one should not be touched. That will cause direct coupling and will burn whatever this other instrument is also touching. The third one is insulation failure. So this insulation, this instrument or all instruments in laparoscopy will be insulated. The only non-insulated instruments would be instruments like the needle holder, the suction cannula. But otherwise, they all will have an insulation over it. So this insulation needs to be regularly checked by the nurses and the CSSD staff who are sterilizing these instruments to ensure that they do not have any break in them. They can be manually explored. It's not the most accurate way, and then there are instruments that can be used to explore this. I mean, there are techniques that can be used to explore this instrument to see that there is no break. Because when there is a break, if I'm activating it here and it's causing the burn there, if there is a hole here and bowel is touching here, this bowel will get burnt because of lack of insulation here. So it burns here where you want it, but it burns also here where you don't want it. So you do not want insulation breaks in your instruments. So regular inspection of the instruments is extremely important to avoid insulation failure risk. Finally, to now give you the final safety tips on use of the monopolar energy or electrosurgery in general is number one, your instrument, I mean your equipment, you can see, should be very audible. So this is very audible. Make sure that it's audible and set at a level above the rest of the instruments in the theater. Okay? If it is set low, then you will have an issue with inadvertent pressing of the button by mistake and someone not knowing that they have pressed it. Okay? Whereas if it is audible enough above the rest of the sounds, when you press it by mistake, or if someone presses by mistake, you will immediately say, okay, who pressed what? And you will immediately, your job is to look for where the active electrode is. So if the active electrode is on the patient, just lying on the patient like this, and it was pressed by mistake, I guarantee you there'll be a burn there. So you try not to leave the volume low, put it up at a higher volume, and immediately there's an inadvertent pressing of the button, look around and see that the instrument that you have is safely secured somewhere. Second rule, the cords should be free of kinks and knots. So no knots here and no unnecessary kinks, and definitely don't tie it around a metal instrument like a towel clip. The third thing, the operator always should confirm the settings, all the settings that are for the electrosurgery before he or she starts to use it. It's not the job of the staff around you to do that for you. It's still your job as the captain of the ship to verify the settings, confirm the settings, and then start off with using it. The next safety tip is whenever possible, this electrode, when it's not in use, should be kept away in a safety holster on the side of the patient. So it could be in the pouch or in a hard safety holster, where if activated by mistake, it is inside a safety holster. Finally, it's important that when you want to cut, the best rule for cutting is you need traction and counter traction. So it cuts best with some tension in the tissue, and it coagulates best when there is no tension in the tissue. So you try and coagulate it when they are together, and when you want to cut, you separate it and then cut, and it separates very nicely. So these are rules of use of electrosurgery, especially monopolar, and the safety tips around it. Thank you very much. So with this, we come to the end of the second part, and as we move on, we will now go into part 3 about bipolar. So see you next time discussing bipolar energy.